I bet most of you have come across with vectors in your previous course. But right now, I would like to focus on dot products between two vectors. I know that you know by heart that when we mention about dot product between two vectors, you will see that it will give you scalar value, which is quite contradict when you would like to determine the scalar products between two vectors, which will give you new vectors. That will be discussed in the next lesson. So basically, the reason why we end up having scalar value is through this theorem, which can be derived from geometric point of view, which is the dot product between vector AB, which will be like what you see on this setup, equal to magnitude of vector A times magnitude of vector B times cosine theta. So from here onwards, when we derive it, you will end up having the scalar value, which is when you have two vectors, so you have to perform the multiplication according to the coordinate, and then you sum them up all together. Let's discuss this example where the question gives to you two vectors such as vector v and vector w. Vector v consists of 3, 2, 1, meanwhile vector w consists of 3, 1, 5. And then we ask you to determine the dot product between these two vectors. So basically what you will do is that you will multiply according to the coordinate, which is x with x, y with y, and z with z, and then you will find the summation between x with x, y with y, and z with z. So for this question, 3 times 3, 2 times 1, and 1 times 5. So you will end up having 16 as your answer. Based on the theorem that we get when we observe the vectors from geometric point of view, which is the dot product between two vectors, vector A and vector B, is equal to magnitude of vector A times magnitude of vector B times cosine theta, we can use it to find the angle produced by two vectors, or we can also use the theorem to determine whether two vectors are parallel in the same or in the different directions. Okay, let's take a look at the elaboration on how to use the theorem to show that they are parallel in the same or different direction. So for the case of parallel in the same direction, by having that kind of illustration, we can safely assume that our angle theta is equal to 0. And then by putting theta is equal to 0 into the theorem, in order to show that two vectors are parallel in the same direction, you have to show that this expression is true, such as the dot product between two vectors, which is vector A and vector B, is equal to the multiplication between the magnitude of vector A and magnitude of vector B. Other than that, in order to show that the vectors are parallel but in the different direction, by having that illustration, you can safely assume your angle theta is equal to 180 degree or pi in radian, and then you have to put it into the theorem, and then you have to show that this expression is true, such as the dot product between two vectors, which vector A and vector B, is equal to the negative of multiplication between magnitude of vector A and magnitude of vector B. Based on the geometric interpretation of the dot product, I have explained how to utilize it to determine the angle between the two vectors. Now let's put it into practice, where this example asks us to determine the angle between two vectors, such as vector v consists of 1, 1, and 1, meanwhile vector w consists of 1, negative 1, and 1. So in order to use the formula to determine the angle between these two vectors, we have to recall the formula. So basically we have to find the dot product between two vector first, which is we have to perform the multiplication according to the component, such as I with I, J with J, and K with K. So in this case, right after I perform the dot product between these two vectors, I will end up having 1 as the answer. And then according to this formula, I need to determine the magnitude of each vectors right after that, which is the magnitude of vector V is set 3, meanwhile magnitude of vector W is also set 3. So by manipulating the formula, cosine theta is equal to the dot product between vector V and vector W, and then divide by the magnitude of both vectors, and then I will get 1 over set 3 times set 3. Set 3 times set 3, you will end up with 3, and then by find the inverse of cosine, 1 over 3, and at the same time you have to make sure your calculator is in degree mode, then you will end up having that answer, which is 70.53. Now let's take a look at this example, where this example asks us to determine whether vector U is parallel or not to vector V for question A, which is vector V is equal to 4i minus 6j plus 10k. And at the same time, the question also asks us to test whether vector U is parallel or not to vector B for vector V for question B, which is I minus 3 over 2j plus 2k. So right now, what should we do? So according to the explanation that I have shared earlier, in order to determine the parallelness between two vectors, so we have to show that the dot product between the two vectors is equal to the multiplication of vector U, magnitude of vector U, and magnitude of vector V. So in this case, I have to find the dot product between two vectors, which in this case U and vector V for question A. So I will end up having 76 as the answer. And then right after this, what should I do? I have to determine the magnitude of each vector separately. So in this case, I will get the magnitude of vector U equal to set 38. Meanwhile, the magnitude of vector V is equal to set 152. So I have to find the multiplication between the magnitude of vector U and magnitude of vector V. And then I will get set 5776, and then if I'm using my calculator, I will get set 5776 is equal to 76. So right now, since we are able to show that the expression is true, such that the dot product between two vectors U and vector V is equal to the multiplication between the magnitude of the two vectors. So I managed to show that 76 is equal to 76. Therefore, U is parallel to V. So that is the notation for parallel. So basically, this is how you show the parallel symbol in mathematics. And at the same time, since I have 76 equal to 76, so I can conclude that these vectors parallel to each other in the same direction. Okay, for example 2, again the same question. I have to show that the vector U is parallel to vector V. So in this case, my vector V is equal to I minus 3 over 2j plus 2k. So right now I have to find the dot product between these two vectors, and I will end up having 32 over 2 as the result for the dot products. And then again, what I'm going to do right after this, I'm going to determine the magnitude of each vector, which is in this case the magnitude of vector u is equal to set 38. Meanwhile, the magnitude of vector v is equal to set 29 over 4. So according to the expression, in order for this vector to be parallel, so you have to be able to show that the dot product between two vectors equal to the multiplication between two magnitude of the two vectors. So in this case, set 38 times set 29 over 4, I will get 551 over 2 set 551 over 2. So obviously u dot v is not equal to magnitude of vector u times magnitude of vector v, such as 33 over 2 is not equal to set 551 over 2. Therefore, u is not parallel to vector v. So as simple as shown in the calculation. So I hope you get the way to present the parallelness between two vectors.